Every Shopify app you will ever build ends up talking to one endpoint. One URL, one post verb, one entry point object called the QueryRoot, and a version number in the path that expires on a schedule Shopify publishes over a year in advance. Today we cover the Admin GraphQL API from first principles, the schema, the versioning scheme, and the query patterns. Everything else in this series builds on using nothing but Shopify's own current API reference. Welcome back to Shopify Development Deep Dive. The Admin API is how apps read and write everything in a store: products, orders, customers, inventory, discounts. Since October 1, 2024, the REST Admin API has been legacy, so GraphQL is not one option among two anymore, it is the API. Everything you'll see in this episode is quoted verbatim from Shopify's current reference documentation, pinned to API version 2026-07, the current stable release. Here's the plan. First, the single endpoint every admin API request hits, and the access token header that authenticates it. Second, Shopify's quarterly, date-based versioning scheme: how long a version lives, and the fall-forward behavior when yours expires. Third, the QueryRoot object, the schema's entry point, and how fields and arguments select exactly the data you want. Fourth, connections: the edges in node structure GraphQL uses for lists, and the shorthand that makes it less verbose. And fifth, cost-based rate limiting: why a complex query costs more than a simple one, and how to read the cost object Shopify attaches to every single response. Here's the whole lifecycle on one slide. You pick an API version, they're date-based, like 2026-07, and a new stable one ships every quarter at 5 p.m. UTC. You send a post request to the graphql.json endpoint on the store's own domain, with that version embedded in the path. You authenticate with an x-shopify-access-token header every request, no exceptions. Your query enters the schema at the QueryRoot, the single object every queryable thing hangs off of. And the response comes back with an extensions block carrying a cost object, your live rate limit ledger, attached to every reply whether you asked for it or not. What you need to follow along. A development store, or, if you don't have one handy, Shopify provides a free read-only demo store with a hosted GraphQL Explorer where every query in this episode runs as is. If you use your own store, you'll need an admin API access token, which you create in the admin under settings, then apps and sales channels, then develop apps give it read scopes for products, orders, and customers. And any HTTP client works. Shopify's own documentation demonstrates everything with plain curl, which is exactly what we'll mirror. This is the real authentication example from the reference, and it shows the whole transport in 5 lines. A post to the store's own domain, path admin, API, the version, graphql.json. Content type is JSON, and the access token rides in the x-shopify-access-token header. The body is a JSON object with a single query key holding the GraphQL document as a string. This tiny query asks the shop object for its name and that shape. A post with a query string in a JSON envelope is every admin API call you will ever make. Queries here are the equivalent of a GET and REST, but they all travel over post to this one endpoint. These rows are quoted from the real release schedule table on Shopify's versioning page. A new stable version ships every 3 months, and each one stays accessible for a minimum of 12 months, with at least 9 months of overlap between consecutive versions. Look at the top row: version 2025-07 stops being accessible on July 16, 2026, tomorrow, as this episode is produced. And the versioning page documents exactly what happens if your app is still pointing at a retired version. Shopify falls forward and serves your request using the oldest accessible stable version instead. Your call still works, but against a schema you never tested. The response header x-shopify-api-version tells you which version actually answered. If it differs from what you requested, that's your warning sign. The reference's own first example: get the ID and title of the first 3 products. Read it from the outside in. Products is a field on the QueryRoot, the schema's entry point that you never name explicitly in the query itself. First: 3 is an argument, and for list fields like this one it isn't optional, you must bound the result set. Then edges, node, and finally the 2 fields we actually want, ID and title. Nothing else comes back: no descriptions, no variants, no images, because GraphQL returns exactly the fields you select and not 1 byte more. That's the core trait against REST: you write more up front, and you stop overfetching forever. This is the real QueryRoot example from the Queries Guide, and it demonstrates something REST simply can't do: 2 unrelated branches of the schema fetched in one round trip. The shop object with its billing address child object, and the products connection, side by side in a single request. Note the response IDs. Every node in the admin API has a global ID in this GID format: GID, Shopify, the type name, a number. Those GIDs are how you address any specific object anywhere in the API, and the response JSON mirrors the shape of your query. Exactly what you select is precisely what you get back. And here's the real single node example. The customer field on the QueryRoot takes a required ID argument, one of those GID strings, and returns one customer object. Then you list the fields you want from it: display name and phone. Arguments are key value pairs attached to a field that parameterize what it returns, and they're how the same schema serves both. Use one object by ID and list many objects with a bound. One more practical note from the docs: many REST endpoints return an admin _GraphQL API ID property that's the bridge, the exact GID you can feed into a query like this one when migrating old integrations. Connections represent relationships between types, and this real example nests one inside another, the first three products, and for each, its first three variants: product data and variant data, in a single request. Notice it uses nodes instead of edges. The docs are direct about this. Nodes is shorthand for edges wrapping node, and it's appropriate for most queries. You reach for the full edges form only when you need data that lives on the connection itself, like pagination cursors. Every connection, at every depth, needs its own first or last argument. That bound is a key component of how Shopify manages rate limiting and pagination, and the API will reject an unbounded list. Connections also accept a query argument for filtering, using Shopify's search syntax, the same field :value grammar you may know from the admin's own search boxes. This real example asks for the first two orders whose fulfillment status is shipped, and gets back orders 1592 and 1564, both showing fulfilled. Which fields a given connection can filter on is documented per connection in the reference. On that connection's query argument it varies, so check before you build a filter. Between arguments, nesting, and this search filter, you can usually shape the exact result set you need server-side instead of overfetching and filtering in your own code. The admin API is not rate limited by request count, it's rate limited by calculated query cost, measured in points. Each field costs points, and a query's total cost scales with how much it could possibly return, so more complex queries cost more to run. This is the real extensions block from the reference, returned on every response. Requested query cost is what Shopify estimated before running, actual query cost is what it truly consumed. Throttle status is your bucket, a maximum of 1,000 points available here, 997 currently remaining, refilling at 50 points per second. Read this object on every response and you always know exactly how close you are to the ceiling. No guessing, no waiting for failures. Here's the trap that catches every developer coming from REST. GraphQL status codes are different. The API returns 200 OK in cases that would be 400s or 500s in REST, so checking the HTTP status is nowhere near enough. This is the reference's real sample error: a query whose cost, 2003, exceeds the single query maximum of 1000. The error arrives inside a 200 response, as an errors array with a machine-readable code. Max cost exceeded, and the message itself points you at the fix: bulk operations, which get their own episode later in this series. The reference documents the other common codes too: throttled, which is their 429, access denied, their 401, shop inactive, and internal server error. Always parse the errors array. The recurring mistakes, gathered in one place. Always check the errors array in the body, because a 200 response proves nothing on this API. Pin an explicit version in your endpoint path and retest each quarter. The fall forward behavior means an expired version doesn't fail loudly, it silently answers from a newer schema. Request only the access scopes your app actually needs. That's not just hygiene, it's Shopify's own stated policy for keeping the platform secure. Bound every connection with first or last, and keep an eye on the cost object as your queries grow nested and complex. And treat access tokens like the passwords they are. They belong in headers, never in URLs, never in client-side code, never in logs. Pulling it together. The Admin GraphQL API is one endpoint, opposed to Admin API version, graphql.json, authenticated by the access token header. Versions are date-based and quarterly, each supported at least 12 months with 9 months of overlap, and after that, fall forward quietly serves your requests from a newer version. Every query enters the schema at the query root, and fields with arguments select exactly the data you need and nothing more. Lists are connections nodes for the common case, edges when you need connection-level data like cursors, and every one of them must be bounded. And rate limiting is cost-based, a 1,000-point bucket refilling at 50 points a second, with a full ledger attached to every response you get back. That's the Admin GraphQL API's foundation, the endpoint, the versioning clock, the query root, connections, and the cost-based throttle. Part 16 takes the next step: mutations, writing data instead of reading it, and the user errors handling patterns that separate production apps from demos. If you're building along with this series, subscribe now so you don't miss it. Thanks for watching, and I'll see you in Part 16.